Hello guys, welcome once more online. Now if you've ever had a problem with questions in physics on mirror or problem with questions in physics on echo, this section is going to address that problem. Now this is JAM Physics 2015 and we shall be looking at question number 26 to number 30, and in the midst of this question we shall be meeting questions on echo and mirror and we shall be destroying them. Don't forget that if you learn anything from this video, click on like button. We have loads of content to send to you that will better help you clarify physics, because physics is what should be clarified. Let's get to number 26 now. It says an object is placed 15 centimeters from a converging lens of focal length 12 meters. The image of the object is formed by the lens. Formed by a lens is what? Now it is an image, and you can see the word, it is a diverging lens, right? Now let's take a look at that now. This question is a mirror question and it shall be solved with the mirror formula. Ever you hear the word diverging lens in physics, that tells you that your F should be negative. So now I'm trying to find the image. What is the image of the image of the object? The image of the object formed by a lens. So now what is the image? That means how far is the image from the lens? Now what will be the image? Now this is the object and this is my image. So I'm trying to make V the subject of formula. So the first step is to make V stand alone, and therefore you will do that. The first thing to do is to find the LCM. Find the LCM of F. The LCM of Find the LCM of F, U, and V. Find the LCM of F, U, and V, and that will become FUV. So put the LCM beside all of them. FUV, FUV, FUV. Now F cancels F. I'm left with UV. That will become minus UV. Then U cancel U. I'm left with FV, and that is FV. Plus V cancel V. That's FU, and that's FU. But remember, I am trying to make V stand alone because V is the image of the object. So therefore, I have V here and I have V here. I have to bring them together. That means this one here will come over here, and this one that doesn't have U and V here, this one FU that does not have V will jump over to this side. That will become minus FU because it has moved from the right hand side to the left hand side. It will become negative. Minus FU equals FV plus Y plus UV. Y plus, because the minus UV here, when it jumps to this side, it will become positive. It will change from minus to plus. That's FV plus UV, and that's what we have here. Then make V. Now factorize V because V is common. So bring it out. V is common. I'll be left with what? F plus U. That is factorizing V, and that's what you have there. Excuse me. Now, so we have V equal bracket F plus U. Then I have minus FU equals V bracket F plus U. Now remove the F plus U, bring it under the minus FU. That will become V equals minus FU over F plus U. And that's the formula to use to answer this question. Now plug in the parameter. So I have made V the subject now. I can now plug in the parameters. So now what's my F? 12 minus 12 bracket. What's my U? The object placement is 15 centimeters. Over the F, 12 plus U, 15, and that will give me 12 times 15 is what? Minus 180 over 12 plus 15 is 27. 27 divided by 180 is 6.67 minus. The image is virtual since it is a negative. Since it is negative, why? How do I know that it is negative? It is virtual because it is negative, and virtual means that it is formed behind the mirror, and that's since it is negative, and it is 6.67 from the lens, and that is it. So the image distance is 6.67, but since it has a negative value, that means it is virtual. So the answer is virtual and 6.6 centimeters from the lens, and that's how we answer questions in mirror. Now don't forget that it's very important that the ultimate formula for mirror is 1 over F equals 1 over U plus 1 over F. But if ever you are told that something is diverging, and its length, diverging length, it will become negative for F. Please take note, it is crucial and very important. And that brings us to number 26 as B. Number 27 says, which of the following type of lens is suitable for correcting the eye defect illustrated by a diagram by the ray diagram. Now this eye defect is actually long-sightedness. That means because this object is close by, the image is formed behind the eyes, behind the retina, and that's why this person can't see. Because for you to see this place, this eye here must be here. It must be formed on the retina, because the retina in the eyes is right here. That means if you are looking at something and that thing is formed at the back of your retina, you can't see that thing. And that's why people that are long-sighted can't see close objects. People that are long-sighted can only see things that are far. And the reason why they can see it is because when it's far, the image is formed at the retina. But when it comes close, the image is formed, it moves to the back of the retina, and therefore they can't see. So this is a long-sightedness case. And let's check it out now. How do we correct it now? This is just it. The word long-sightedness can also be called hypermetropia, and it is corrected by what? A convex lens. Can you see that? You know that the word convex lens is also called a converging lens. So that means for this ray to scatter, before it goes to the back, a convex lens will make it closer. It will close up easily, faster. So if you close up, this lens will make it close up faster, and it will, instead of spreading to the back, it will close up faster and form on the retina right here. So that means the answer to this eye defect, to this hypermetropia or long-sightedness, is just a convex lens, which will form the image right on the retina, forbidding the image from going to the back of the eyes. And that is the answer. So let's remember that long-sightedness is corrected by a convex lens, but short-sightedness, if it is short-sightedness, it is corrected by a concave lens. Don't forget, short is concave, long is convex. Super easy. It is not more than that. That's just it for eye defect, and that's just the answer to that question, by a convex lens. And that convex lens is also called a converging lens. Okay, they didn't put a convex lens in the option. It is actually another word for convex lens is converging lens, because it's why? Because it converges the image from going to the back. It converges here. So it is also a convex lens or a converging lens, not a diverging. A diverging lens is a concave lens, but a convex lens is a converging lens. That is another name for convex lens, and that's biconverging lens. Biconverging lens, and that's the answer. It should be just a converging lens. I don't know what they mean by biconverging, but it is supposed to be just a converging lens, and that is the answer to the question number 27. Let's check number 28. A swimming pool is 2.1 meter deep. If it contains water of refractive index 1.3, calculate the apparent depth of the pool. Now, this question is under a topic, okay, in physics called expansivity. At the end of expansivity, you will see something like this, or you can also classify it under refraction, depending, because you can see refractive index. But however, now, have you ever been to a swimming pool and you're looking and you see that the person inside the water is bigger than he actually is? Yes, when people swim in the water, like fishes or whatever, they look bigger if we are looking at them from outside. That is the function of refraction, and the index or the size, the ratio of their magnitude in the water to their original size is called the refractive index. What I mean is that the ratio of that is how much has it increased. That magnitude is called the refractive index. So the ratio of the original person to the size you are seeing in the water is called the refractive index. And the answer, the refractive index, is given by the formula real depth over apparent depth. Don't forget, it is real depth over apparent depth. That is the refractive index. For anything in water, it is real depth over apparent depth. And therefore, I will be getting my refractive index 1.3 equals the real depth that you are seeing, that is in the water. The ordinary depth you are that is in the water, not the one you are seeing, but the one that is the natural depth of that person is 2.1. But the apparent depth is as it appears to your eyes. Okay, and that is what we are told to find. Calculate the apparent depth. So it is real depth over apparent depth. That is the refractive index. 1.3 equals 2.1 over apparent depth, right? Now make apparent depth the subject by multiplying both sides by the apparent depth. So if I put it here, I'll have AD times AD cos AD, and that is AD equals 2.1 divided by 1.3. and that will give me 1.6 meter, and that is my answer for the apparent depth. Don't forget the formula for anything refraction. The real depth over the apparent depth is the way to go, and that is the answer for number 28. Number 29, when an air column is set into vibration, the distance between two successive nodes of the resultant wave is what? Now this one is just something to be explained very quickly. If in the air column or in sound wave, distance between two nodes following each other, that's successive node, is what? What is the distance? This diagram will explain that now. Now this is a node, and this is the next node, and this is the next node. Okay, node. The distance between two node following each other is what? It's never, you can see, it is what? 1/4 of the wavelength, okay, or 1/half of the wavelength, or the wavelength, or twice of the wavelength. You can see the distance between two nodes is what? This is a node, and this is next node, and that's what we have, wavelength over 4. So the answer is going to become 1/2. Why is it 1/2? And I'll tell you why. The answer is 1/2 because this is a node and this is the next node. What is the distance between them? Half of it is 1/4. Half of it is 1/4. 1/4 plus 1/4 gives you 1/2, and the answer is therefore 1/2. Because if you mathematically, if you combine 1/4, okay, plus 1/4, you will get 1/2, and that is half. 1/2 is half, and therefore the answer is 1/2. So what I'm saying in essence is that the distance between this place and this place is 1/4 combined with 1/4. 1/4 combined with 1/4 will give me 1/2, and that is my answer for the distance. Is half of the wavelength. So don't forget that against next time. Distance between two nodes is 1/2 of the wavelength, and that is the answer to that question. Let's check out the last one. A girl standing some distance from the foot of a tall cliff, clap her hand, and hears the echo. So this is the echo question. 0.8 seconds should be seconds later. Calculate a distance from the cliff. Speed of sound in air is 320 meters per second. Now let's check that out. What is the echo formula? You must know that the echo formula is derived from the velocity of wave formula. Echo formula is V equals F lambda, or you can say it as V equals 2D over T, depending on what you want to use. So it can be, this V is what? Velocity of wave, F is my frequency, and lambda is my wavelength. Why 2 is 2, D is distance, and T is time. Now in this question we were talking about time, 0.8 seconds, that's time, and we're talking about to find the distance, and we're given the speed, right? That's V. Okay, so that means I can't use this one that has frequency or wavelength. I can only use this one that has 2D over T, because I was given the distance and I was told to find so I was told to find the distance and I was given the time, and that means I will use V equals 2D over T. Don't forget that this formula can be either this one or this one or this one, depending on what you have in your question. So my answer is therefore going to become, I'm finding D, right? I'll make D the subject. So if I cross multiply, I'll have 2D equals VT, right? Dividing these two out, remove the 2, it will come under, it will become VT over 2. Now what is my V? My velocity is therefore 320. Then times my time, T, is 0.8 over 2, right? 320 divided and times 0.8, get the answer divided by 2, you will get 128 meters as your distance. And it all came from the formula V equals 2D over T, or V equals F wavelength. And that is how to solve any question on echo. In fact, this formula can solve anything on echo. I'll repeat again, this formula can solve anything on echo in physics. Please take note of these two formulas. You can either use this one or this one, depending on what you have in your question. And that gave me my answer for 30 as C. And that brings us to the end of this session. Don't forget, if you learned something from this video, click on like button. We have more content that we can send to you that will better help you understand physics. Until we see you again, guys, take care of yourself and bye for now.